Good morning, you guys. Sorry I can't be with you today. I think I mentioned to you the other day that I'm actually at a conference in San Antonio. So I'm going to kind of let you watch this short video with the notes, and hopefully you'll have plenty of time to complete the notes as I go through the video, and then also to work on the homework in class and get it all done. Don't forget that you're supposed to submit homework online. Okay? So now we're on the section 7.2 notes, and look at the top, graphing polynomials. It says that the degree and leading coefficient, this is what we learned the other day in class, the degree and leading coefficient.
Kirsten Johnson to the front
Did you hear that? I wanted to make sure you felt at home with Miss Holden on the announcements. Okay, the degree and leading coefficient of a polynomial determines the end behavior of the polynomial. Remember how we said degree tells you if both ends are up or if they go in an opposite direction, and the leading coefficient then, kind of helps you determine whether it's up or down or whatever. Okay, what we're going to bring in today, which is something we've mentioned a while back but haven't done a lot with, we're going to do a lot more with it today, and that is that the solutions to the polynomial, okay, so this is kind of new-ish today, the solutions to the polynomial determine the zeros, or remember we said the zeros are the same as the x-intercepts or the roots of the graph. So something that we might have talked about before, if I have, let's say the parabola, and let's say it's in factored form, y equals, I don't know, how about x plus 2 times x minus 3? Well, I know the zeros are going to be x equals negative 2 and positive 3. What that means is, if I were to graph that parabola, I'm going to have a 0 over here at negative 2. I'm going to have a 0 over here at 3. And since I know this is a parabola, then I know it's going to be opening up. But remember, it's the zeros that, the solutions that determine the zeros on the graph. Okay, one more thing we're going to add in is something called multiplicity. And multiplicity just means the number of times a linear factor occurs. It's the number of times a linear factor occurs for a particular polynomial. Okay, that's what is called the multiplicity. Multiplicity. Okay, for example, and this is really what's going to drive it home. In this particular equation, right, I've got the quantity x plus 1 to the fifth, and then I have the quantity x minus 1, and even though there's not an exponent on that second parenthesis, it's an implied 1 right there on the outside. Okay, well, both of those are linear factors. X plus 1 is linear because it's just x to the first. X minus 1 is linear because it's just x to the first. The two linear factors are x plus 1 and x minus 1. And the multiplicity for the x plus 1 is 5, because do you see that 5 is the exponent? That means you have x plus 1 times x plus 1 times x plus 1 5 times, right? And the multiplicity for x minus 1 is just 1 because there's only one of those. So the multiplicity is the number of times a particular parenthesis occurs, or in other words, it's the exponent on the parenthesis. Okay? I don't know if that's helpful. It's the exponent on the parenthesis. Okay, so here's what we're going to do with that. Look at the next page at my examples. It says, first identify the solutions, meaning what will make it equal 0, and then label those as the x-intercepts. And then it says, use your calculator to sketch the graph of each of the following. Now, here's the thing. I don't want you to just go straight into the calculator. I want you to start by finding the zeros. So on letter A, if I were to set this equal to 0, I know I would get x equals negative 3 for that last parenthesis, x equals 2 for that middle term, the x parenthesis. And then because there's a common factor of x out in front, don't we get a possible solution of x equals 0? So there are 3 solutions. What that means is there are 3 x-intercepts at 0, at 2, and at negative 3. Okay, so let me do one more. Before we go to the calculator, let me do one more. Let's say I'm looking at letter B. Well, when I look at letter B, if I were to set this equal to 0, I'm going to get x equals negative 1 for the first parenthesis, positive 1 for the second parenthesis, And that -3 out in front is just a constant, so that doesn't give me a solution. Whereas over here on letter A, when I had that -5x squared, because there was an x out in front, that gave me a solution of 0. So on letter B, I'm going to have an x-intercept at -1 and an x-intercept at +1. Okay, so what I want you to do right now is maybe pause the video and go ahead and do what I did, where you just find the zeros for the rest of these terms, C, D, E, and F. So just pause it for a second and fill those in. Okay, before we go to the calculator, maybe you should just do a quick comparison. Make sure that your zeros for C, D, E, and F are the same as mine. If you need to pause, do that, but check and make sure. And now what I'm going to do is I'm going to take that first equation, letter A, and I'm going to put it in my calculator. Let's do this. I'm going to put that in my calculator, and then we're going to draw the graph. Okay, so let's pull the calculator up here. Let's see, there we go. Let's move this over here. Beautiful. So I'm going to put in the 0.5x squared. Okay, so 0.5x squared, and then I have parenthesis x minus 2, and let's get rid of that, and then I have the parenthesis x plus 3, x plus 3. Okay, I'm just going to go with a kind of a standard window, and yours, let's see, this is probably more like your standard window. Okay, notice that the zeros that I have at -3, 0, and 2 are the same as this graph. And if I were to kind of draw it in, let's see. It looks like it comes down, comes up, and bounces at 0, and then back. Not perfect, but close, right? Okay. Why don't we go ahead and put in letter B. So go back to your y equals, clear that out. Put in -3, and then parentheses x plus 1 and x minus 1. Oops, that x plus 1 was squared, sorry. And then we have the parentheses x minus 1, and that one is squared also. Okay, so make sure you get the squares on the parentheses. And when I graph that, same window, well, notice it does touch at the two zeros that I have listed, right? 1 and -1. But do you see that it actually kind of bounces off of both of them? Comes down to here, something like that. So it does something like that. Okay, not perfect. That one actually looks a little higher, but I think it's just because it's a different window. If I put it on a window closer to the one I have on the paper, it's something like that, right? Okay, so what I want you to do is go ahead and put in the rest of the graphs, C, D, E, and F, put them in your calculator, draw them, kind of pause the video so you can kind of get those on. And I'm telling you, you guys, if you're going to be tempted to just leave the video go and just draw what I draw, but you're going to get a lot more out of it if you actually get used to using the calculator and doing it the way we would normally do it in class. Okay, so please pause and use your calculator and draw in those graphs. Okay, hopefully you've graphed all of those on your calculator and put them on, and you're kind of comparing to what I have, and hopefully we're pretty close. And so now I want you to look and see what this says at the bottom. It says, study the graphs and the multiplicity of each linear factor. Remember, the multiplicity is the exponent on each individual parenthesis. And it says we're going to make some generalizations about the behavior of the graph at the x-intercepts. Okay, what's happening on the graph at the x-intercepts? And notice it says when the multiplicity is even versus when the multiplicity is odd. So in other words, when I look at, let's say, number 1, the x equals 0 came from the factor 0.5x squared, right? And notice the multiplicity on that x is a 2. So that's an even, right? And look what happened at x equals 0, that particular 0, the graph bounced off. I'm going to say B for bounce. Now compare that to same equation, but let's say over here the factor x plus 3, right? The 0 was -3, so we're talking about the one over here on the left. Notice the exponent on that parenthesis is a 1, right? If there's not one there, you assume it's a 1, which is odd, okay? So on that one, look at my graph, it just passed right through that point. So according to letter A, when my multiplicity was even, the graph comes and bounces off of that point, but when the multiplicity was odd, it actually passed through that point. So let's go find, let's go over to letter C because it has one of each. Okay, so on letter C, let's look at x minus 1, right? The multiplicity here is 1, and notice at the 0 right here, 1, the graph passed through that 0. But look at the other one, this x plus 1 to the 5th, right? That one, I was wrong about having one. That one also is odd, right? So this one has an odd multiplicity. And on that particular 0, did the graph pass through? So here's one where the multiplicity was odd on both, and the graph actually passed through. Let's see if I can find one. Oh, I know. Go down to letter F. If you go down to letter F, so the x minus 3, right? The x minus 3 here, the multiplicity is 2. So at that 0, over here at 3, because the multiplicity was even, do you see that the graph comes down and it actually bounces at that point? It doesn't actually go all the way through the x-axis. Whereas if you look at the first factor, x right here, that's to the first, right? It has an odd multiplicity, and yet at that 0, the graph actually passed all the way through. So let's see if we can kind of write this as a, I can get my cursor. Let's see if we can write this as kind of a rule, okay? How about if we say this? How about for even, we're going to say that the graph bounces off of the x-axis. So if your multiplicity is even, the graph bounces off of the x-axis. Bounces off of x-axis. In other words, it doesn't actually pass through the x-axis. It comes down, it touches it, and goes right back. And then if it's an odd multiplicity, those are the kind where the graph actually passes through the x-axis. So graph passes through the x-axis. Okay, so let's put all of this together, including what we learned yesterday. On number 1, here's what I know. So there are zeros at -2 and 1. Okay, that means I'm going to have x-intercepts at -2 and 1. The degree of the overall polynomial. So if this had been multiplied out, now I don't actually have to do it, but if I had squared out the x plus 2, on that I would have an x squared at the beginning, right? And if I took that big old term and multiplied it by an x minus 1, do you see that overall our degree for the entire polynomial would be 3, right? Because this multi out, if I actually did it, I would have x squared plus 4x plus 4 from the first part. And if I took that and multiplied it by x minus 1, if I went through all the multiplication, do you see that I would end up with an x cubed at the beginning? Okay, so the degree there would be 3. The leading coefficient of that x cubed is just going to be 1, because there's no number in front of this x, no number in front of this x for when they get multiplied out. So leading coefficient is just 1. More specifically, what we care about, it's positive, right? So what does that mean about the end behavior? Well, if the degree of the polynomial is odd, doesn't that mean it's going in opposite directions? And if it's a positive leading coefficient, so doesn't that mean that it's down on this side, but it's going to be up on this side? Okay, so now let's put that together with the multiplicity. So remember my factored form. At x minus 1, right, that's this 0 over here. At x plus 2, that's this 0 right here. Well, x plus 2 has an even multiplicity. Do you see that right there? The even multiplicity. So that means at that 0, it's going to come up and it's just going to bounce off. It's not going to actually pass through. But then this one, where it had an odd multiplicity, right, the exponent is 1, it's going to actually pass through, which makes sense because in order for it to head up to where I had the end behavior, it's got to fit that way. Okay? So for the end behavior, if you want to actually write something in that blank, basically we said it was down on the left and up on the right. Okay, so look at number 2. So let's start by putting on our zeros at -2, +1, and -3. So -2, +1, -3. Okay? The overall degree, if this were multiplied out, this x is to the first, this x is to the first, and this is going to end up being an x squared. So the overall degree is going to be 4 If I were to multiply all this out, I would have an x to the fourth, right? But notice the leading coefficient over here is going to have that negative. So leading coefficient is going to be negative. So what does that mean about my end behavior? Well, it's even, so they're in the same direction. Because it's negative, doesn't that mean both ends are going to be going down? So on this side, it's going to be going down. And then on this side, it's going to be going down. So let's put that together with the multiplicity. Okay, I like to start at the left and work my way across. So at -3, that's my first zero. That comes from this factor. Notice it has an even multiplicity, so that means it's going to bounce off at that zero. I'm going to move over to the one at x equals -2. That comes from this factor. Notice the multiplicity right here is a 1, so it's odd, so it's going to pass through that one. And then the final zero comes from this x minus 1, which also has an odd multiplicity, so it's going to pass through that point, which makes sense. It has to if I'm going to head back down. Now, I'm not saying this is the exact graph, but it's close. Okay, and finally, let's do one more. Let's put on the zeros at 2, 1, and -3. So 2, 1, and -3. The overall degree of the polynomial, the first one is a 1, and then this one is a 4, this one is a 3. If it were multiplied out all together, I would have a total degree of 8. Notice out in front, it's positive, so the leading coefficient is positive. So what does that mean about my end behavior? Well, if it's an even degree with positive, doesn't that mean both ends are going to be going up? So from this side, I'm going to be going up, and from this side, I'm going to be going up. All right, so now let's put that together with the multiplicity. I like to start at the left. So the -3 comes from this factor. All right, the exponent is 3, so it has an odd, so it's going to pass through. And then I go over to the one at 1. So that comes from this factor. Notice the 4 is my exponent. That's an even multiplicity. So at that number, it's going to come up and bounce off. But then over here at x minus 2, that had an odd multiplicity. So it's going to come back and go through that point. So there's kind of my overall graph. Again, it may not be the exact graph, but it's close. Okay? So that's what you're going to do in your homework, is basically what I just did right here, put it all together. And like I told you guys the other day, this is the beginning of what I was talking about that we'll use every day in that one specific chapter in calculus. So help each other if you need to, but really go through these carefully. All right, good luck. Make sure you remember to do all of section 7.2 homework and then submit it online. Do not go on to 7.2b.